This is Unit 12 Test Review, Exponential and Logarithmic Expressions. This review is also going to count as your extra credit. So everything that I have highlighted in yellow is what we're going to do together. Everything else you're going to complete on your own and turn in for those 10 points extra credit. So starting with number one says given f of x is equal to log base 3 of x, what transformations occur in the graph of f of x is equal to negative 3f parentheses negative parentheses x minus 3 plus 3. So remember, anytime we see this f in here, we have to rewrite our equation in terms of f. So this log base 3 of x. So I'm going to have f of x is equal to negative 3 log base 3 of negative x minus 3 plus 3. Okay, then I'm going to label all of my transformations. So that's labeling my A, B, C, and D. So A is negative 3. A has two things happening. It has the negative, which tells us that there is a reflection over the x-axis, and then the 3, which tells us that there is going to be a vertical stretch. Then we have B is equal to negative 1. This tells us that there's going to be a reflection over the y-axis. C equal to x minus 3 means we are going to go right 3. And then D equal to 3 means we're going to go up 3. Okay. So those would be our transformations. Remember, you're not going to get all the rules on the test. You need to go back and memorize what is going to give you each of the stretches, compressions, reflections, and all the other directions for transformations. Number 2, you're going to do on your own. This one, you're going to turn y is equal to 2 to the power of x, and you're going to do each of the things it's telling you to do here. So you are going to reflect across the x-axis, vertical stretch by 2, 3 right, and 1 down, and then you're going to label that as g of x. Number 3 says, given the function f of x is equal to 2 to the power of x, answer the following questions. So this is an exponential equation, and notice that it gives us this on our graph already. So this is the original equation here. We have to do the following question. So part A says find the domain and range of the function. So the domain for exponentials is always all real numbers, so negative infinity to positive infinity. And our range is going to depend on our asymptote. So the asymptote here is going to be at y equals 0, because notice it is not going down, because it is not going down below that line. So this is going to be a range of 0 to infinity. Okay. Part B says sketch the inverse function. Part C says what is the domain and the range of the inverse function. You're doing those on your own. Part D, where it says find the inverse function, we're going to do that together. Okay. So remember that the inverse function for an exponential is in terms of log. So 2 to the power of x, we would just change this into log. So our original one is y is equal to 2 to the power of x. We would turn this into log by doing log base 2 of x equals y. So this would be our inverse function. Okay, number 4, you're going to do that on your own. You're going to solve for x. So remember, you need to get the bases the same. Number 5, we're going to do that together. Number 5, we have 36x is equal to 1/6 to the power of 2x minus 1. So remember, if we start off with the whole number and go to a fraction, that tells us that our exponent is going to be negative. So exponent is going to be negative. I'm going to write that off to the side. And then I have to think, okay, how can I make these be the same base and I have 36 and 6, okay, because I'm looking right here at the bottom. Well, 36 is the same as 6 squared, and 6 here and 6 in the denominator both match. So this can be written as 6 to the negative 2 power. So instead of 36, I'm going to write it as, sorry, 1 second. Okay, so I'm going to write this as 6 to the second power, because that's 36, is equal to, well, 1 over 6 can be written as 6 to the negative 1 power. Then I'm going to bring down everything that was already there in the exponent. So I'm going to bring down that x and bring down that 2x minus 1. And now that our bases are the same, I can cancel them out and then just solve for the exponent. So 2x is equal to negative 2x plus 1. Add the 2x over, so 4x is equal to 1. Divide by 4, x is equal to 1/4. That is our answer. Number 6, you have to solve the following equation. Remember, before you solve, you need to have your exponential by itself. So you're going to have to divide by 2. Okay. Number 7, we're going to solve here. Notice again, we need to have the same base. Well, we know that 27 is the same as saying 3 cubed. So I could rewrite this as 3 to the power of 3x plus 2 is equal to 3 cubed. The bases match, so I can cancel them out, and I'm left with 3x plus 2 is equal to 3. Then I solve for x. So subtract the 2, so 3x is equal to 1. Divide by 3, x is equal to 1/3. Number 8, you're going to have to expand this using the properties of logs. And then number 9, we're going to do together, and we're going to do the opposite. We're going to condense this into 1. So first thing, following PEMDAS, I'm going to do these first 2. So since they are being added together, this tells me that I'm going to use the product rule and change it into multiplication. So this is log base 6 of 16 times 54. And then I'm going to bring down the minus log base 6 of 4. Now I have this minus, which tells me I'm going to use the quotient property and divide. So this is log base 6 of 16 times 54 divided by 4. If I put that into the calculator, this gives me log base 6 of 216, which is 3. Number 10, you have to solve the following equation. And in order to do that, you're going to have to change this log into an exponential. We're going to do that here on number 11. I'm going to change this log into an exponential by circling my base, doing my loop around, and pointing to my parentheses. So now this is going to be 3 to the power of 1 is equal to 6x minus 12. Well, 3 to the power of 1 is 3, so 3 is equal to 6x minus 12. Excuse me. Add the 12 over, so 15 is equal to 6x. Divide by 6, so x is equal to 15/6, which is equal to 5/2. I just reduced my fraction. Okay, number 12 you're going to do on your own. Number 13 we're doing together. Says the number of giant pandas Y born in captivity X years after 1990 is shown with the data table below. Use an exponential regression to find the number of years after 1980 that the number of pandas born in capacity surpasses 400. So we would first have to find our equation using list and spreadsheets. So our TI Inspire, you would go to list and spreadsheets, type in the table, so all the data that's in that table. Then you would hit Control-I to open up a new document. Select Data and Statistics. Place the variables on the correct axes, so X goes on the bottom and Y goes to the left. And then you would hit menu, 4, which is analyze, 6, which is regression, and 8, which is exponential. When you do that, you would get the answer y is equal to 26.24 times 1.126 to the power of x. Well, we need to know what x would be if we're trying to find the value that would surpass 400. So 400 is equal to 26.24 times 1.126 to the power of x. Well, in order to solve this, we would have to either solve by using algebra. So we would get the exponential by itself by dividing by 26.24, then changing this into a log. Or what you guys could do is you could type this onto your calculator using menu 3.1, which is nsolve, and you would type this in exactly. So it would have nsolve. You would type in 400 is equal to 26.24 parentheses 1.126 to the power of x, comma x. And what that comma x does is it tells the calculator what variable to solve for. And when you do that, you'll get x is equal to 23, and then when you can't forget the unit, so 23 years. Okay, we're going to do number 14. It says a sports car priced at $60,000 depreciates, so $60,000 depreciates at a rate of 14% per year. The value after t years is given by the following equation, where a is the amount after depreciation. How long to the nearest year will it take for the car to depreciate to $18,000? So we're going to write that equation. A of t is equal to 60,000 times 0.86 to the power of t. It wants us to find t, so this a of t is actually 18,000. So I'm plugging that in. And then in order to solve for t, just do menu 3.1, the nsolve that I described above. And this time you would do comma t because that's your variable. And you would get t is equal to 8 years. Okay, you're going to do 15 on your own. And 15 is similar where you will be solving for t. We're going to do 16 together. So it says, how long will it take $25,000 to grow to $500,000 at a 9% interest rate compounded continuously? So we're going to use that formula, compounded continuously. So A is equal to P times E to the power of RT. So for this one, we're trying to see what would give us 500,000. So that's our A. 25,000 is our P. 9% interest, that's the same as saying R is equal to 0.09. And then we are trying to find T. So this is 500,000 is equal to 25,000, okay, times E to the power of 0.09 to the T power. So again, we're trying to find T. You're going to use that menu 3.1 like I showed you on the calculator, and you're going to use comma T to find the time, and you're going to end up getting T is equal to 33.286 years. Sorry, my thing's acting up a little bit. Let me try that again. T is equal to 33.286 years. Okay, you're going to do 17 on your own. Okay, so this is the same thing. So it says use your model to estimate the population. So this one you're actually going to be finding A. And then 18, we're going to do 18 part A and B, and then you need to do C and D. So 18 says your deposit of $1,500 in an account that pays 8% annual interest. Find the balance after 1 year if the interest is compounded within the given frequency. So first we have to find annually. So that means we're using the compound interest. So we have 1,500 and then 1 plus 0.08, that's our R, okay, divided by 1 year for a total of 1 year is equal to 1,620, so $1,620. Quarterly, we have 1,500 times 1 plus 0.08 divided by 4, because it's happening 4 times a year, to the power of 4 times 1 gives us 1,623.65. You're going to do the same for daily. So hint, your N is equal to 365. And then you're going to use the formula for compounded continuously.